In this video, we're going to address solving trigonometric equations with multiple angles, and that's example 13. So if you take a look at our problem, it says cosine x, and then it has cosine 2x. Also had plus sine x multiplied by sine 2x. And this whole thing equals to square root of 3 over 2. What do you think? How are we gonna solve this problem? I'm gonna let you think for a couple of seconds. If you need more time, just pause here and think. What does the left side of this equation reminds you of? What I see here is that we have cosine A, cosine B, where A is x, B is 2x, plus sine A times sine B. And that reminds me of the formula for the cosine of A minus B. All right, so instead of this whole thing, I'm going to write cosine A minus B, where A is x and B is 2x. So what are we going to get? On this side, we have cosine of x minus 2x equals square root of 3 over 2. All right, so that gives me cosine of negative x is square root of 3 over 2. And using the fact that cosine is an even function, cosine negative x is the same as cosine x, and that equals square root of 3 over 2. Now, from the unit circle, we know that this happens only when x equals pi over 6 or 11 pi over 6. And in the problem, they told us we need to find the x from that period from 0 to 2 pi. So we're done with this problem. We used identity to basically fold this whole left side into just one cosine. Again, how do you know which one to use? There is no hard set rule. You just basically look at the equation and ask yourself, what can I do here? What does it remind me of? Which formula can I apply here? And go from there. It's the matter of experience. The more experience you'll get with working with those equations, the easier it will become. So it's important to do your homework. All right, so the next problem that I want to discuss in this video is example 14, where it says solve the equation exactly using the double angle formula. Well, here they actually give you a hint, the formula that you need to use. But what if they didn't, and you look at this problem? So what is the issue here? Well, you have a cosine of 2 theta on the left side, and you have a cosine of theta on the right side, and they're not the same angle. So this may as well be angle A, and this is angle B. So that means this is not just, you could not factor 2 from inside the trig function. All right, I'm going to repeat that again because I've seen people trying to do that. You cannot factor 2 out from inside the trig function. You cannot factor anything out. You cannot factor anything in. If it's inside, it's sealed. You cannot just pull it out arbitrarily. But what you can do, you can actually transform this cosine 2 theta into something that will have only theta. Remember, we have our double angle formulas that we covered earlier. And those formulas, that's actually what they told you here. So what are those formulas? Let's recall them. Here they are. It says that the cosine of 2a could be written as cosine square a minus sine square a, or 2 cosine square a minus 1, or 1 minus 2 sine square a. Now, out of these three possibilities, I'm going to choose the one that has the same function that's on the right side of this equation, because I think that's going to be the easiest to solve. So I'm going to choose 2 cosine square a minus 1. So instead of cosine 2 theta, I'm going to write 2 cosine square theta minus 1, and that equals to cosine theta. Now this becomes an equation quadratic in type, right? So I'm going to do my u substitution. U is cosine theta. So u squared is cosine square theta. Substituting in, I'm going to get 2u minus 1 equals u. Now bringing u to the other side, I will have 2u minus 1 equals 0. Now, how do we solve this equation? Hopefully by factoring. So I'm going to use my magic X technique. So I'm using for two numbers that will multiply to -1 and -2. It's 2 times -1. So -2, they multiply to -2 and they add up to -1. Well, such numbers are -2 and 1. And then I'm going to split this negative u using these numbers. So I have 2u minus 2 2u squared. 2u squared minus 2u plus u minus 1 equals 0. And now I'm gonna factor by grouping. I'm gonna do this group and I'm gonna do this group. Okay, so I'm factoring 2u. So I'm gonna have u minus 1, and I'm factoring just 1 out of this group because there's no common factor. Okay, now factoring u minus 1 out, I'm left with 2u plus 1. So now I have two equations. I have u minus 1 equals 0, or 2u plus 1 equals 0. Keep solving for u. I'm going to get u equals 1 for 1, and u equals -1/2 for the other one. Now I'm supposed to solve for theta, right? So, and that's what I was saying at the beginning of this section. First, you're going to do the algebra part. So you're going to use your algebra and solve the algebraic, linear, or quadratic equation. And then once you're done solving the algebraic equation, you're going to go back and solve the trigonometric equation. So you're going to recall that u is the cosine theta, and you're going to write cosine theta equals 1, or cosine theta equals -1/2. And now you're gonna solve these trig equations. Well, we know that for cosine theta equals 1, that happens only in one place. Well, 0 or 2 pi k. Do we have a restriction? No. 0 plus 2 pi k. No restriction on the domain, so we have to describe all of the solutions. So that's just 2 pi k. And for the second one, the cosine, where cosine equals -1/2. So that happens in two places on the circle. It's 2 pi over 3 and theta, this is not q, this theta, and 4 pi over 3. So those are two solutions for this equations. And again, we're gonna add 2 pi k on top of them, where k is plus or minus 0, plus or minus 1, plus or minus 2, so forth. Okay, so that's how you're gonna approach this example. And the last type of problem that I want to address in this video is the problem where you have a multiple angle. Okay, so this problem is actually pretty simple. So if you don't look at the interval for now, it's just we have a trig function on one side and a number on the other side. So it looks pretty easy, right? So even though there is a double angle inside of the function, you don't have to deal with it at the moment. Okay, so what I recommend is just, so you have a trig function isolated. You don't have any other trig functions in this equation that you have to match it with. We don't have other angles that we have to match. So there is actually nothing that we have to worry about in this problem. So in order to see that, I encourage you to, again, to do the substitution. So we're going to call 2x a y. And what happens? Our equation becomes cosine y equals 1/2. And we already know how to solve those types of equations, right? They're pretty straightforward. So we have two angles that satisfy that equation. It's pi over 3 and also 5 pi over 3. So this is what we're gonna write. We're gonna say y is pi over 3, right? But we also are gonna add 2 pi k on top of it. Or y is, what was it, 5 pi over 3? And add 2 pi k on top of it. Okay, so now we found y, but we need to find x. That's what the original equations say, x. So let's plug in, write these equations in terms of x. We're going to have 2x equals pi over 3 plus 2 pi k. And here 2x equals 5 pi over 3 plus 2 pi k. And now, in order to solve for x, we have to divide both sides by 2 or multiply by 1/2. So times 1/2, left side and the right side. And we're going to have x equals 1/2 times pi over 3 is pi over 6. And now 1/2 times 2 pi k is going to be just pi k. Okay, on this side, we're going to do the same thing. So 1/2 and 2 cancel each other. So we have x equals 1/2. So 5 pi over 6 plus pi k, where k is 0, plus or minus 0, plus or minus 1, and so forth. Okay. Now out of these equations describe all solutions. Okay, now out of these solutions, we have to choose ones that satisfy our domain from 0 to 2 pi. So we're gonna plug in different values for k and see if our angle falls into this region. So we're gonna start with k equals 0. So x is gonna be pi over 6 plus pi times 0, which is just pi over 6. So this satisfies. Now, what about this one? Here we have 5 pi over 6 plus pi times 0. So that's 5 pi over 6. Okay, so what happens when k equals positive 1? We're going to have x equals pi over 6 plus pi times 1, which is 7 pi over 6. Is it in the domain? Yes, it is. What about the next one? X equals 5 for the second solution, 5 pi over 6 plus pi times 1. So we're going to have 6 pi over 6 plus 5 pi over 6. That's going to give us 11 pi over 6, and that's still within this interval. So we're good. What about when k equals 2? We're going to have x equals pi over 6 plus pi times 2. So 2 pi is 12 pi over 6 plus pi over 6. That's 13 pi over 6. That already is outside the range. This is bigger than 2 pi. So this is not in the domain. So, well, I'll write that later. Okay, and the same thing is going to happen for our second solution for 5 over 6 plus 2 pi. Well, you could just know that it's 2 pi plus something. That's already going to be too big, right? So outside, our interval stops at 2 pi. So something bigger than 2 pi is disqualified right away. So let's write it down, disqualified. I don't even want to calculate what it's going to equal to. And this one is disqualified. Okay, and you can also try, like, for k negative, when k equals -1, -2, it's gonna actually also be a fall out of this interval, but on this side, on the negative side, you're gonna get negative results. So the only results that are good are right here. The only results that satisfy that actually that interval are these four: pi over 6, 7 pi over 6, 5 pi over 6, and 11 pi over 6. So this equation has two solutions. To summarize it all, when you have a multiple angle here, first you're gonna solve this simple equation, and then and substitute the multiple angle with something simple, solve for that variable, and then you're going to plug your angle back in and solve for the original variable that you were given. In this case, it was x. Solve for x, find all of the solutions. So these guys are general solutions. I'm gonna actually point it out. So these right here, they're all possible solutions. All possible solutions. And then once you have all possible solutions, you're gonna basically pick the ones that satisfy your conditions right here between 0 and 2 pi. But if they didn't give you the interval, then you would just write this as your answer, all possible solutions. All right. So I hope this is clear, and this is the end of this video.